We already learned how to graph a line using the point plotting method. Well, let's apply it to this equation. So for the point plotting method, we start by constructing a table of values, and those values represent solutions to the given equation. So we make 3 columns. In the first column, we're going to place x values. In the second column, we're going to place y values. And in the third column, we'll put them together as ordered pairs, like that. Let's remember, to find a solution to the given equation, we start by giving a certain value, any value that we want, for either x or y. Well, let's think, what would be the good or easy number to use? So let's say I want to pick something for x. I know that once I pick that number, I'll have to plug that into the equation and then calculate or solve for y. What would be the easiest number to plug in? Well, it should be something small, and the best one is actually 0. Why 0 is the good number? So I'm gonna pick 0 for x. Well, because once I plug it in here for x, 2 times 0 will become 0, so this whole thing will be gone and I don't have to deal with it at all. So let's write this all down. Let x be equal 0 and see how it's gonna work out nicely. So it's 2 times 0 plus 3y equals 12, and because I use 0, this term just goes away, and I'm only left with 3y equals 12, which I can easily solve by just dividing by 3 on each side, right? So y equals 4. Y equals 4. So when x is 0, y is 4, and the ordered pair I get is 0, 4. Okay, so hopefully you agree that it was pretty quick and easy. Well, since it was so good, let's repeat that, because, well, we need to find more solutions. And let's now pick 0 for y, because remember, we can choose either x or y to start with. Let now y be equals 0. So that means that in my equation, I'm going to plug in 0 for y. It's going to be 2x plus 3 times 0 equals 12. Once again, the term where I'm multiplying by 0 goes away, disappears, and I'm only left with 2x equals 12. And then from here, as I divide by 2 on the left and on the right, I find that x equals 6. So when y is 0, let me place it here, right? I picked 0 for y, and then I found that corresponding x value is 6. So I got 0.60, like that. Okay, so far we already have 2 points. How many points do we need to construct a line? Well, 1 point is not enough, right? Because if I plot 1 point, there are so many different ways I can draw a line through that 1 point. But as soon as I add another point, there's only one way that I can draw a line. There are 2 points. That means that generally 2 points is the minimum requirement for graphing a line. But a lot of times we like to pick one more point or find one more solution, kind of like a test point. What if we miscalculated something here? So finding and plotting one more point will help us to identify or find mistakes. So to make my computation easier for the third point, I'm gonna let x be equal, let's say 3. So if x equals 3, let's calculate what y is gonna be equal to. I'm gonna write it over here. So let x be equal 3. I'm plugging in 3 for x plus 3y equals 12. So 2 times 3, that's 6. See how when it's not 0, we have more steps to do. Minus 6 minus 6, I'm trying to find y. So 3y equals 6. And then once I divide by 3 on each side, I'll find that y has to be equal to 2. So when x is 3, y is 2. Here's one more solution. And if they all align, once I plot them, if they're all going to be on the same line, it means that I calculated them all correctly. Well, let's plot them. That's the next step. 0, 4. So it corresponds to 0 on the x-axis and 4 on the y-axis. So that point is here. Or the way you can think about it is I start at the origin, then I have to go right or left according to the first number, well, according to the x, but it's zeros, right? So I don't move either right or left. And then I switch to the y coordinate where I have to go either up or down. Since it's positive 4, I'll go 4 up. So now 6, 0. Start at the origin, move 6 to the right, and then 0 steps up or down. So I'm here, staying here at this place. And then 3, 2. Start here, go 3 steps to the right, and then 2 steps up. Like that. Yes, I can see how they're all aligned. It means that I calculated those solutions correctly. Now I'm going to connect those 3 points with a straight line. Okay, so that's what I got. And that's going to be the graph of the given equation. Now, what we looked at is the point plotting method, and we showed all steps. However, there is more to this example, and this is what I would like to point out. Notice that 2 points that we plotted are kind of special ones. The first point that we plotted, that's here. Notice that this point is not just on the line, well, because it's a solution to our equation, but it's also on the y-axis. So in other words, it's the point of intersection of our graph with the y-axis. Well, for the reason this point has a name, it's called y-intercept. Again, that's where our graph crosses the y-axis, y-intercept. And there's one more like that, and this is the point here. So what kind of point is that? Well, that's the point where our graph crosses the x-axis. So you might guess what the name of that point is. It's going to be the x-intercept. And in general, they're called intercepts of a graph. So a lot of graphs have different intercepts, and they all have exactly the same meaning. These are going to be the places where that graph crosses either y or x axis. And let's talk about or remind ourselves how we found those 2 points. How do we find x and y intercepts if we are asked to find them? Well, what do we have to do to find the the y-intercept, the first one? Well, that's the point here. So 0, 4 is the y-intercept. How do we find 0, 4? Well, that's when we let x be equal 0, right? Let x be equal 0 and calculate the corresponding y value. Well, that's going to be the y-intercept. And the second one was the x-intercept. And we found it by letting y be equal 0. So in other words, when you let either x or y be equal 0, and you find one of the intercepts. So that's another method. It's kind of like a special case of the point plotting method. Sometimes you may be asked to graph an equation by finding its intercepts. And that's what you'll have to do. You let x be equal 0, find y. That's how you're going to find y-intercept. And then you let y be equal 0, find x, and that's going to be your x-intercept. Let's just practice that a little bit more. I have 2 pictures here. They're already graphed, but we just need to determine intercepts, locate them, by looking at the graphs. So once we read intercepts, we right away have to think or look where graph crosses x and y axis. So this graph crosses the x-axis here at this point. What is the coordinate of that point? Well, the x-coordinate is 2 and the y-coordinate is 0. So that is the x-intercept, because at this point graph crosses the x-axis. And that's where it crosses the y-axis. So that must be the y-intercept. And the coordinate of that point is 0, -3. So these are the intercepts of this graph. By the way, it's also common to describe x and y intercepts by just one number. So then in this case, I would say x-intercept is 2 and the y-intercept is -3. And then for this graph, well, notice how it's just a vertical line. It crosses the x-axis at -1, 0. X-intercept, remember, in the name, the variable matches the variable of the axis. x-axis, x-intercept. So that is -1, 0. Or I can just say -1. And does this graph cross the y-axis? No, they actually go parallel to each other, right? So that means that there are no y-intercept. No y-intercept. And that's possible. So for some graphs, it's possible to either have no x-intercept or no y-intercept.